Well, hello, pre-calculus students and seekers of general truths. Let us continue our study of polar functions by doing some analysis of this graph right here. And then, of course, we will graph this function so you can see what it looks like. Now, some of the things that we're going to talk about here is the domain, right? So we still want to find the domain. We will want to find the range. We will talk about something called the maximum R value. Okay, and I'll explain that in a minute, and as well as the minimum R value. Okay. All right, so now keep in mind the domain here, we're talking about values of theta. What is it that I'm allowed to plug in here for theta? Well, no, not surprisingly, I have the sine function, so I can plug in anything I want into theta, and so our domain is going to be negative infinity to positive infinity, also known as all real numbers. The range here is going to be the R, or the radius. Now again, keep in mind that we are plugging in theta and we're going to get R. Okay, and we're going to use the sine function here. So if you look at some reasoning here, the original sine function has range -1 to 1. When we multiply this by 3, we're going to end up with range -3 to 3. And then when we add 3, we're going to shift it all up by 3 units. So if we were to graph theta versus R, right, the graph is going to look something like this. It's going to go as high as 6 and as low as 0. Right? So this is just if we were to graph theta versus R on the XY plane using rectangular coordinates. So this isn't the answer, but this will help us with the answer, that the range, the possible values for the radius is going to vary between 0 and +6. Let me clean this up here. I don't know why I drew all those lines in there. It would be 0 and +6. Okay. Next, we are going to talk about the maximum R value. So the maximum R value is the greatest distance, okay, and distance here is the operative word, from the origin, or from the pole, if we want to use polar terms, from the origin, not the original, the origin. Okay. And in this example here, if we look at the range, right, the R value is the range. The biggest R value that we could have here is 6. The minimum R value in this problem is going to be the smallest distance, or the shortest distance from the origin. And I want to emphasize here that we are talking about distance, okay? And distance is always positive or 0. It's never negative. So distance can never be negative. All right. So the minimum R value in this case happens to be 0. In other scenarios, we will see that it might be a little bit different. All right. So without further ado, let's actually graph this in polar mode and see what we got. All right, and so we can see here from this graph, this is in polar mode. This is what it looks like. And up at this point here, this is where the maximum R value occurs. Okay. So it occurs because you can see here that this is the distance from 0 to that point is exactly 6. And then this right here is where the minimum R value occurs. Okay, so the radius, in other words, is at its very, very smallest, right at that point. And yes, this curve will go over all 4 quadrants. It will go into the X negative side and the Y positive side, because again, every single one of these points that we're graphing is R theta. It's very unusual because we're graphing r theta on an xy plane. Okay, so the axes here is still the x-axis and the y-axis, but the points that we're graphing is using the polar system. So that's what we have there. All right, so with that, let me end this video here, and we will continue with a couple more examples where we see some things that are a little bit more complicated.